Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4, going to present about chitin polymer. So my name is Siti Hajar binti Azaman. My metric number is 193250. My group members Nur Farhanim Zaidi 192599 and Nur Farahana Suzaini 192594. The content we are going to present today is definition and structure, physical properties, processing, analysis and application of chitin. So next, Hana going to present about definition and structures of the chitin.
Assalamualaikum and hi, I'm Hana. So today our group will discuss on topic of chitin. So chitin is a significant natural polysaccharide that is generated from immense number of living organisms. And it is also second most abundant polymer after cellulose. These are the sources of chitin. It can be found on the exoskeleton arthropod as well as the cell wall of the fungus and yeast. And currently, shrimp and crab shell are the primary commercial sources of chitin. Here are the chemical structure for chitin and chitosan.
Hi, my name is Nur Farhanim and I'm going to proceed with the physical properties of chitin. So, in its pure form, chitin is translucent, pliable, resilient and quite tough. However, in most arthropods, it is largely occur as a component of composite materials such as in sclerotin, a thin proteinaceous matrix which form much of the exoskeleton of insects. Chitin is highly hydrophobic and is insoluble in water and most organic solvents.
This is a processing step to produce chitin. Firstly, load in raw material that can be from waste of crab shell and others. Secondly is the most critical step, which is extraction of chitin. This step covered deproteinization and demineralization, which is to remove the protein and mineral from the raw materials. After that, wash and clean to remove the residual chemical from the previous step. Then, dry and screen to remove unwanted or foreign material from the manufactured chitin. Further drying is necessary by using natural sun drying to ensure that the chitin is completely dry. Last but not least, grind the chitin into the desired size and also to be in uniform as the company wanted. The video here will show the process that I explained just now. As I mentioned earlier, extraction method is the most crucial step to ensure that it gives the high productivity of chitin. So extraction method can be done by chemical and biological. These are chemical extraction method. Deproteinization is the removal of protein by using sodium hydroxide, and it is quite difficult to do due to the disruption of chemical bond between protein and chitin. Demineralization is the removal of mineral, which primarily is calcium carbonate, by using hydrochloric acid. So this is a very easy step. Lastly is the method to preserve the chitin structure. So this is the treatment to obtain the chitin with high deacetylation and also high molecular weight, yet free from protein and mineral. Then for biological extraction method, deproteinization is done enzymatically using protease. However, it is less efficient than chemical method and need to do further treatment by using sodium hydroxide to retain the chitin structure and purity. Next, for fermentation method, it can be done with or without lactic acid. With lactic acid, lactobacillus strain can be used, while for non-lactic acid, bacteria and fungal can be utilized for the fermentation process.
Hi, my name is Siti binti Azaman. I'm going to present about analysis of chitin. So there are several things that we are going to be tested on chitin polymer, such as degree of acetylation, protein content, H content, and pH value. But today we are going to be more specific on degree of acetylation analysis. And why is it important to analyze chitin? It is because to reduce large amounts of unstructured content, to describe characteristic of content, which is the characteristic of chitin, and as well as to expect important aspect of the chitin. Degree of acetylation. Degree of acetylation of chitin affects variety of features including solubility, chemical reactivity, chain conformation, electrostatic characteristic, and biodegradability. That's why we need to know the degree of acetylation of the chitin. There's several ways of testing the DA. But today I'm going to be specific on nuclear magnetic resonance spectroscopy approach (NMR) and pyrolysis gas chromatography approach (GC). For nuclear magnetic resonance spectroscopy approach, which is NMR, there are several types of NMR, which is three types, which is HNMR, the application of nuclear magnetic resonance in NMR spectroscopy with respect to hydrogen 1 nuclei within the molecules of a substance in order to determine the structure of its molecules. Second is NMR, the application of nuclear magnetic resonance in NMR spectroscopy with respect to nitrogen 15 nuclei within the molecules of a substance in order to determine the structure of its molecule. And the last one is CNMR, the application of nuclear magnetic resonance in NMR spectroscopy respect of carbon 13 nuclei within the molecules of substance in order to determine the structure of its molecule. So there is three types, which is H hydrogen, C carbon, and N nitrogen. But HNMR is the most sensitive and precise technique, and the result is the most accurate data, which is the technique is applicable for a limited range of DA, which is degree of acetylation, where the polymer samples are soluble in a solvent. For CNMR and NNMR, CNMR and NNMR can be used for soluble and insoluble samples in the entire range of the pyrolysis gas chromatography, the technique for detecting acetic acid utilizing gas chromatography (GC) and acid hydrolysis with hydrochloric acid. The heat degradation of materials in an inert environment or a vacuum is known as pyrolysis. Therefore, the weakest links in large molecules break, resulting in smaller, more volatile pieces. Gas chromatography can be used to separate these pieces. The data can either be used as fingerprint to prove material identity, or GCMC data is to use to identify individual fragments to obtain structure information. Eventually, infrared, HPLC, GC, UV, and NMR are all extremely instrumental methods worth examining in determining the quantity of protein, H, pH, and degree of acetylation. Further, it has been demonstrated that this spectroscopic approach may be utilized to successfully distinguish and acquire the content inside the chitin or chitosan, such as amide, amino residues, while examining protein and degree of acetylation.
So I'm going to proceed with the application of chitin. In agriculture, chitin is used in as defensive inducing mechanism in plants. In biomedical and pharmaceutical, chitin is used in sponge and bandage for the treatment of wound and suture treats. While in water engineering, chitin is used for decontaminated plutonium containing wastewater and water containing methyl mercury acetate. Furthermore, chitin also used in cosmetic category, where it is used in toothpaste, mouthwash, chewing gum, and dental filler material. Chitin also used in textile industry for printing and finishing preparation. And last but not least, chitin used in food processing industry as and used in immobilization of enzyme.